everyone. I once again welcome you all to the online classes of Girls High School and College. Today, we are going to study geography. The lesson that we have taken is insolation. Now children, sun is the ultimate source of light and energy. Sun is a constantly churning gases and the temperature of it is about 6,000 degrees Celsius. The rays that we receive of the sun are largely absorbed in our atmosphere, and these rays are called infrared rays and the shorter waves are called the ultraviolet rays. And this solar radiation, it provides more than 99.9% of the energy that heats the Earth's surface. Our planet Earth, it is situated at the right position. It is neither too close to the sun like Mercury and Venus, and nor it is too far away from the sun like Jupiter, Saturn, Neptune. Hence, the ideal condition that exists for all forms of life and various climatic and weather processes depends on it. The amount of insolation that is received by the Earth's surface is not uniform everywhere. It is minimum at the poles, and the places which are close to the equator, they have higher temperature and they are warmer and hotter because these are the places that are receiving the direct rays of the sun, and the sun energy does not have to travel a long distance. But when you see the polar areas, the sun energy has to travel a greater extent, and thus to travel a greater extent, the sun rays, they lose heat on their way. Hence, minimum insolation occurs at the poles. Now, here we are going to study about the heating of the atmosphere. Our atmosphere is not directly heated from the sun above, but it is heated by the terrestrial radiation that is given out by the Earth's surface. There are three processes that are involved in the heating of the atmosphere, and these three are called convection, conduction and radiation. Now, in convection, what is happening? The transmission of heat from one part of a liquid or gas to the another by movement of particles themselves is called convection. Now, what is happening? That the heated air, it rises up, being lighter. Now, as you know, that the same phenomena is happening on the Earth's surface. That the Earth is here and the atmosphere, the air that is just above the Earth, because of this radiation, it gets heated. As soon as it getting heated, it becomes lighter, it rises up, and the colder air from the above comes and takes place. At higher level, the rising air spreads horizontally, gets cooled and sinks again. As it comes down, it spreads and gets heated and ascends again. So it is an ongoing process. Thus, several circulations in the air are maintained due to the process of convection. Convection is an upward movement of air which has been heated by the contact of the Earth's surface, and this air is said to rise in a convection current. Conduction is a process in which heat is transferred directly through matter from a point of high temperature. Conduction transfers heat between adjacent molecules till the temperature is equal. Heat passes from warmer to colder substance as long as temperature differences exist. Now, what happens? When you heat a pan and you touch the handle of the pan becomes hotter. Now, when your hand is having other temperature, the pan handle is having other temperature. So when you are going to touch, what happens? The heat is transferred because there is a difference. So that is what it is telling, that heat passes from warmer to colder substance. Thus, when the Earth's surface absorbs radiation and warms the air above it, conduction transfers part of heat to the lower layers of the air. Now comes radiation. Now, radiation, it is the process by which a body emits radiant energy. Now, energy that is received from the sun in the form of heat, it causes a loss of heat and therefore leads to cooling. During the daytime, maximum of solar radiation is being received by the Earth's surface. At night, Earth tries to emit that radiation, and therefore the atmosphere is warmer at the night time. But it happens only till the minimum is reached. Long wave electromagnetic radiation originates from the Earth and its atmosphere. It is the radiation emitted by naturally radioactive materials on the Earth, including uranium, thorium, and radon. Now, differential heating of the land and water. Land and water surface, they have quite different properties in absorption of and radiation of the heat. Now, land surface, it is rapidly heated and it intensely heated also under the sun rays, whereas water surface, it gets moderately heated. On the other hand, it says that land surface, it cools off more rapidly, and that is why temperature contrasts are created over the land mass, but only moderate over the sea. Now here we are going to study about the factors that are affecting the distribution of temperature. Normally, the horizontal distribution of temperature is determined by latitudes. As you know, we have learned about the heat zones that determines the latitude and the temperature. The general decrease in temperature from equator towards the pole is one of the most fundamental and best known fact of climatology. If the effect of latitude were only controlling factors affecting net radiation, we would expect the world map to have isotherms lying parallel to each other. Isotherms are the lines that are joining places that have same temperature. So it is said that all the places of that same latitude would have same temperature, but it doesn't happen like that. Why? Because the horizontal distribution of temperature is the function of numerous other physical factors also. There are different physical factors and we will be discussing each one of them one by one. The very first one is latitude. It is said that the places that are close to the equator, they have higher temperature and are warmer and hotter than the places that are far away from the equator. The equator is the point where direct rays of the sun is being received. The poles are the point where the rays have to travel a greater extent, and that's why they lose their heat while traveling a greater extent. Hence, the heat of these rays is more intense at the equator, but in high altitude, the sun rays are slanting and have to pass through greater extent of the atmosphere. Hence, these rays, they lose heat, and so the area in the higher latitudes are not very hot as compared to the equatorial region. Altitude. The height of a place above the mean sea level is the altitude of the place. The atmosphere, it is mostly heated by conduction. Air is cooler at higher altitudes than near the Earth's surface. With the increase in height, temperature decreases, that we have learnt. And for every 166 meters, the temperature falls by 1 degree. This is known as normal lapse rate. This is the reason that why hill stations, they are very much cooler even in the summer season, because as you are going higher and higher to the altitude, the temperature will be decreasing. Inversion of temperature. The temperature, now this is another thing that is happening, that the temperature decrease at the rate of about 1 degree Celsius per 166 meters or 6 degrees Celsius per 1000 meters of altitude. There are certain situations that are created where temperature decreases. Now there are, however, some places where certain special conditions in the lower atmosphere produces a reversal of the normal lapse rate. Now in the normal lapse rate, we have learned that as you are going higher and higher, the temperature is decreasing. But in the inversion of temperature, what happens, that there are certain times when you are going to a certain area where temperature will increase, not decrease, with an increase in altitude. This is known as temperature inversion. Now this temperature inversion, it appears in the hollows and the valleys of the calm clear nights when radiation had caused cooling and the cold air, it sunk down. At the same time, on the mountain slopes, the air is warmer. Temperature inversion is normally found in the middle latitudes, and for this reason, the fruit growers in these regions, they prefer gentle slopes to valley bottom for orchard sites, distance from the sea. This also influences the temperature. The main contrast in between the land masses and the ocean, as there is differential heating of the land and water. As we have learnt, land gets heated faster as compared to water. Therefore, during the daytime, land gets heated more than the surrounding oceans. This contrast is more visible over the land than over the ocean. On the above basis, we have an oceanic or equable climate, that is marine type of climate, when the areas are close to water bodies. For example, Mumbai is having equable climate. Why? Because that area is having moderating influence of sea on the land surface. But when you see Prayagraj, on the other hand, that is situated at the center, over here we are having extremes of temperature. We are not having any moderating influence of the sea. But here we experience extremes of temperature, that is felt. Such areas experiences continental or extreme types of climate. For example, Mumbai, an extreme type of climate is felt in Nagpur. The next point that we are going to study is the ocean currents. Now, ocean currents, children, they either increase or decrease the temperature of the Earth's surface. There are two types of ocean currents, that is the warm current, which blow from equatorial to the polar regions, and there is a cold current which moves from polar region towards the equatorial latitudes. Now, ocean currents along the coast, they make the coastal areas warmer, and cold current, it makes the coastal areas cooler than the usual. Now, warm current can be noticed on the eastern margins of the continent in the middle latitudes, whereas the cold current, they are found on the western margins of the continent. Now, for example, the Gulf Stream is a warm current and Labrador current is a cold current. Now, winds, they also modify the temperature of a place where they blow. Now, winds which blow from sea to land are called the onshore winds. These winds, they carry moisture, whereas the winds which blow from land to sea are called offshore winds. So beside these, we are also having some local winds like Puhan, Sirocco, Bora, Mistral, Lu, Kal, Baisakhi. Now we will be studying about the slope of the land. Now the relief features and the slope of the land help in modifying the temperature in three ways. Now, first of all, the presence of mountains, they act as a barrier. The Himalayas, they act as a barrier. They prevent the monsoon winds from leaving India, and they also prevent the cold wind from China to enter India. So in this way, these mountains, they act as a barrier. The second point says that the inversion of temperature. The steep slopes, they are experiencing more changes in temperature than the gentle slope because of the reversal of the normal lapse rate. That is also called temperature inversion. That the temperature decreases with height, but in some areas, as we have learned, that and during certain periods of time only, temperature increases with a certain point, with a height in the atmosphere. This is called the inversion of temperature, and this occurs during the winter season over the land. Direction of the slope of the land. Now, the slope that are facing south in the northern hemisphere are warmer than those that are facing the north, because the sun rays strikes the south facing slope at a steeper angle than they do at the north facing slope, which are also called the sheltered slope.